Example 25. Using inverse variation in a practical situation. We've got 5 minutes. Let's get this done. The wavelength, lambda, in terms of in meters of a musical note. Oh, look at that, scrolls away. Is inversely proportional. How do we write something that's inversely proportional? We are going to have lambda, and lambda is nice and easy to draw. Okay? Lambda, boom, boom. And it's inversely proportional to some constant k. So by inversely proportional, it means we put f something over f. What are we going to put over f? Yeah, we're going to put k because k is our constant of proportionality. Okay, that is now inversely proportional. Everyone happy? Pretty cool. All right. Question B. When we did the previous one, I said there's 3 variables in there. How do we find the third variable? We need to have 2 variables, yeah? Guess what they're going to do to us now? Yep, the frequency of middle C. So F equals 260 vibrations per second. And its wavelength equals 1.319 meters. So I have written down those 2. What am I going to now do that I've written down those 2? And sub them in. 1.319 equals K over 260. And I'm not using the units at the moment. I just want to keep it clean numbers so that I can see what's going on. All right, so I got 1.39 equals K over 260. How can I solve for K? Excellent. Multiply both sides by 260, which gives me K is approximately equal to. You guys all recognize that as approximately equal to? Yeah, we can also use the squiggly ones, but my squiggly ones look like my normal equal signs that I'm just terrible at writing. So, all right, what does my answer give me? About 343 meters per second?
Yes.
Happy? Yep. Now, it's an approximate, so I've gone to 0 decimal places. That's all good. And I've also now written the units in, 343 meters per second. Okay? No, not squared. This is not an acceleration. This is a velocity. Now, if you were in physics, we would actually write ms minus 1. Remember? Nope. You can write it either way. I'm doing it the math way at the moment because there's people in here who don't do physics. Weirdos. All right.
What do you mean?
She does more physics in class than you do. Never. All right.
What is the divide sign? What? Too many.
You mean the one that I said is the approximately equal to sign? It is the same as the one, but you weren't listening when I said that that actually looks like my normal equal sign because my writing is horrible. So I use that, and that's approximately equal to as well. All right. Question C says find the wavelength. So what have you got to do to find the wavelength? You're trying to find lambda. But you already know that you've got 343 on there, and it's saying it has a frequency of 440. So you would chuck that in, and you would get lambda equals.
Would it be approximately equals?
Yes. We're all approximately equaling now. Actually, yeah. What's that give you?
343 on 440 is approximately 0.779.
Beautiful. Excellent. Then question D, it says find the frequency, but they've given us. You could. Okay, then round up. I'm happy. All right. Find the frequency when it's got a wavelength of 1 meter. That means your lambda is 1 meter. Equals, well, we already know what K is, 343. And that is frequency.
So it says find the frequency. Find the frequency.
Yep. Lambda is not. Lambda is wavelength.
Wouldn't you rearrange it so that it's clear?
Yep, rearrange it. What do you get?
W range. Oh, okay.
Yep. So I'm keeping it in exactly the same format. You can rearrange the formula first, but I'm just keeping it in exactly the same format that we've already had it. All right. Now, last bit.
Approximate speed of sound in air.
Basic stuff.
What is the approximate speed of sound in air and why? Not based on physics, based on what you've got here.
What? 343 meters per second. My guess. Oh, weird. Yeah.
Why?
Yeah.
Because that's what we worked out as our constant of proportionality. We went, it travels at approximately 343 meters per second. That's what we got. Okay, we've just done 1 meter and we got 343. And don't forget the frequency is vibrations per second. So 343 meters per second.
So if